In 2018, NASA launched an operation with a terrifyingly simple goal. The spacecraft you see here carried a machine called TESS, the Transiting Exoplanet Survey Satellite. Once in orbit, its entire job was to stare continuously at 2.2 million stars. To understand how TESS finds planets, look at this chart representing the transit method. It shows a steady beam of starlight. When a planet passes directly between its star and our telescope, it blocks a tiny amount of that light. The brightness drops by a fraction of a percent, creating the sharp dip you see right there. Over its first 4 years, TESS monitored the sky and sent back alerts for exactly 7,931 of these potential planetary dips. It looked like we had just mapped thousands of brand new worlds. But there was a massive problem. Out of nearly 8,000 recorded signals, scientists were only able to confirm about 700 actual planets. That left over 7,200 potential planets sitting completely unverified on NASA hard drives. The data was there. The worlds were likely there, but no one had the time to look at them. The telescope had done its job perfectly. The true bottleneck in our search for alien worlds was human capacity. We simply lacked the speed to manually dig through that ocean of data and separate the actual planets from the cosmic optical illusions. The universe is full of phenomena that perfectly mimic the exact light dip signature of a real transiting planet. Astronomers call them imposters. Look at eclipsing binary stars. 2 stars orbit each other, causing the light to drop, mimicking a planet perfectly. Next, stellar variability. Stars pulse and generate sunspots, dimming naturally. Third is instrumental noise. A cosmic ray or glitch records a sharp, artificial drop in light. Finally, there's background contamination. You might be targeting a specific star, but a very faint, distant star millions of light years behind it is flickering. That background noise bleeds into your main data feed. To weed out these imposters, human astronomers had to build custom mathematical models for almost every single candidate. They had to book time on other ground-based telescopes to cross-reference the data. A single confirmation could take months. Exoplanet discovery is a forensic data investigation, requiring a processing speed that humans simply lack. In May 2026, researchers at the University of Warwick introduced a different kind of scientist. They built an artificial intelligence system called Raven. Researchers trained Raven on millions of artificial scenarios, forcing the system to map the hidden patterns of real planets against the 4 common imposters. Once trained, Raven was let loose on the real TESS data. It scanned 2.2 million stars, separating the anomalies and assigning probability scores to every dip. Raven delivers the necessary statistical proof instantly, automating validation checks that previously sidelined candidates for months. In a matter of weeks, Raven excavated the stagnant TESS backlog. It officially confirmed 118 completely new planets and flagged another 2,000 highly probable candidates that humans had completely missed. By automating these forensic checks, Raven transformed a years-long backlog into an active discovery stream. It demonstrates how AI can accelerate the scientific verification process. The worlds Raven found are bizarre. It identified planets with ultra-short orbits, where an entire year lasts less than 24 hours. It also precisely mapped out the Neptunian desert, a specific orbital zone entirely stripped of Neptune-sized planets, proving that planetary evolution is far more chaotic than we calculated. For the last 30 years, astronomy was defined by data poverty. We strained to capture tiny fragments of light. But today, we are simply drowning in data. The next generation of telescopes is coming online. Facilities like the Vera Rubin Observatory in Chile will capture roughly 20 terabytes of data every single night. That's the equivalent of downloading the entire text of Wikipedia night after night for years. Global space programs are already adapting. India's space agency, ISRO, is heavily integrating AI and machine learning for their upcoming lunar and Venus missions, simply to process the billions of data points their instruments capture. If 2.2 million stars stalled out human verification capabilities, billions of stars will mathematically break us. AI integration is no longer an optional upgrade. We need it to read the sky. We are scanning millions of stars, hoping to catch the shadow of a world that looks a little bit like ours. But when that signal finally arrives, the first entity to recognize it won't be a human looking through a lens. It will be an algorithm reading the code.